Alrighty, so hopefully you've had a go at this one. The y-intercept is 0, as is the x-intercept. Alrighty. Now these are two strange ones that we haven't had quite much of a look at just yet, but if you have a look, you'll see that this one, the y-intercept is 4, but the strange thing is that there's no x-intercept y because these two lines are parallel, and parallel lines are just never going to touch. If you think of train tracks, you think about what they look like, they're always the same distance apart and they just keep running alongside like that. And so we get the same feature in parallel lines on the page. They're just never going to cross. So in this case, there is no x-intercept. And we get the reverse thing on the next one. The next thing, we can see the x-intercept nice and easily. The x-intercept, that's 2. But once again, now we have vertical parallel lines. And with vertical parallel lines, you will never get them intersecting, meaning there is no y-intercept. Alrighty, so that's a finish of our goal in terms of graphically solving these problems. Now I want us to be able to solve them using an equation. So, it's a little bit different. So, for y equals, alright, so let's take an equation like y is equal to 3x plus 2. Now, in last week's lessons, we were looking at how to solve for the y-intercept. And the y-intercept is equal, well, happens when x equals 0. Okay, so let's do it. So y is equal to 3 times 0 plus 2. Well, y would then equal to 2. So that is our y-intercept. So that means my y-intercept is equal to 2. How do I find my x-intercept? Well, my x-intercept is when y is equal to 0. So this is a little bit trickier. So that means, let's write it in green. 0 equal to, oh, that didn't change the color. Let's try that again. 0 is equal to 3x plus 2. Now, how do I solve for x in this case? Well, the first thing I need to do is I'm going to take 2 from both sides. So it's going to leave me with minus 2 is equal to 3x. And now I'm going to divide both sides by 3. It's going to cancel that out. And I'm going to be left with negative 2/3 is my x-intercept. Alrighty. So, to solve for the y-intercept, I need to look when x is 0. And to solve for the x-intercept, I need to solve when y is equal to 0. Alrighty. So I'm going to give you a slightly different equation. I want you to have a go. I'll give you y is equal to 4x plus 2. Alrighty, so see if you can solve for the x and y intercept. Alrighty, so for the y-int, we're going to go x equals 0. So we get y is equal to 4 times 0 plus 2. Y is then equal, 4 times 0 is nothing, plus 2 is 2. So my y-intercept is 2. What about my x-intercept? Well, my x-intercept is when y equals 0. So 0 is equal to 4x plus 2. Take 2 off both sides like before. Minus 2 equals 4x. Divide both sides by 4. And you're left with a negative 1/2 is equal to x. And if you weren't sure how to simplify negative 2 on 4, your calculator can do it for you. Negative 2, 4. Write it like a fraction, and you'll see it simplifies down to negative 1/2, or negative 1/2. Either way is fine. Even negative 0.5 is fine. It's just different ways of representing the same thing. Alrighty, but let's have a practice of another one. So let's try y is equal to 2x minus 4. Alrighty? So let's do x-intercept first. So x-intercept is when y equals 0. 0 equal to 2x minus 4, plus 4 to both sides. 4 equals 2x, divide both sides by 2, and my x-intercept is 2. My y-intercept, on the other hand, is when x equals 2, x equals 0, sorry. So that means we're going to get y is equal to 2 times 0 minus 4, and that's going to be minus 4. So my y-intercept is minus 4, and my x-intercept is 2. Alrighty, I'll give you one equation. I want you to pause the video, have a go. Have a try of that equation. Pause the video, have a go. Alrighty, so let's have a look. So x-intercept, y equals 0. 0 equal to minus 2x minus 4. Add 4 to both sides. 4 equals minus 2x. Divide both sides by negative 2. 4 divided by negative 2 is negative 2. And that must be my x-intercept. For my y-intercept, x must be 0. And in this case, we're going to get y is equal to minus 2 times 0. Take 4, which means that the y-intercept is going to be minus 4. Alrighty. The last one I want to have a look at is the exceptions to the rule, because I think it's important to always have a look. So let's have a look at y is equal to negative 4x. Alrighty. So y-intercept, x equals 0. So y is equal to minus 4 times 0, which means that my y-intercept is just 0. And let's try to find the x-intercept. Well, the x-intercept is when y is equal to 0. 0 on the left equals minus 4 times x. Divide both sides by minus 4. And 0 divided by negative 4 is still just 0. And we're left with x on the right. So my x-intercept is also 0. Alrighty, last equation for today, we'll do 3x. See if we can find the x and y intercept of that one. Alrighty. Y int x equals 0. Y is equal to 3 times 0. Y int is just 3. Oh, sorry, not 3. 3 times 0 is 0. And the x-int is going to be when y equals 0. And that means we're going to get 0 is equal to 3 times x. Divide both sides by 3. And we get 0 divided by 3 is still 0. The x-int is also 0. And we'll find this as a common pattern. If the x-int is 0, then the y-intercept also has to be 0. It's just a back and forth. And if the y-intercept is 0, the x-intercept is also 0. Because where does it meet? It meets, going back to our visual understanding, at the origin. And so if one of the intercepts is 0, both of them are 0 by definition. Okay? So, hopefully you found that not too difficult, and I'll see you next time where we're going to be sketching these graphs.